And so today, I'm very delighted to feature Mariam Hamzat as a speaker for this event. Maria is a skilled mobile engineer at Rapture Entertainment and a woman Techmaker ambassador. As a FlutterBytes Community manager, her dynamic leadership and passion for tech reflects in community building, event organizing, and engaging presentations. Thank you very much, Maria. Okay, so now it's your turn. Thank you.
All right, so let me share my screen. Okay. Can you see my screen?
Yes. Yeah.
All right. And am I very audible? Okay. So today we're going to be talking about cleaner Flutter code with DAP3. My name is Mariam Hamzat, and a Flutter developer. Build mobile application using Flutter framework. So today we're going to be looking at DAP3 and pattern matching as one of the key features with the DAP3 programming language. So overview of DAP3, right? DAP3 is like a major update in that programming language. And the major update is basically something that the DAP team wanted to, ensure that that programming language is very expressive and maintainable and also versatile in different ways. And we have some key features, which are patterns, records, class modifiers, destruction, improved switch, and if case statement. So what are patterns, right? That is the pattern matching. And I'm sure we'll be hearing like pattern matching is like very, should be very well like this period because everyone now uses pattern matching in whatever like they write in their respective codes. So pattern matching, what are patterns? Patterns are like data shapes, right? They're like data shapes that may or not match in your application. So patterns also have two jobs. After explaining that these terms, I'm going to be showing you a specific situation where you can see how pattern matching works, right? And patterns have two jobs. They can either match the data or they destructure the data into smaller variables. And destructuring the data into smaller variables is called pattern destructuring, which we'll talk about later in this session here. There are some concepts where pattern matching is being used. It's being used in conditional execution, regular expressions, and error handling. This is an example of how pattern matching can be used, right? And I have an abstract class of vehicle that has two properties, name and the number of wheels. Then I have two classes that extend this vehicle abstract class of vehicle. And if you look at this function, right, I'm trying to get the vehicle name, and I don't want to, use if statement to be able to get the vehicle name. Instead, I am using a switch expression that allows me to use pattern matching to be able to get the particular vehicle name. So I'm calling each of the class constructors, right, car. And when I'm calling the car constructor, I am checking, okay, if this vehicle is car, then this whatever I am printing, it prints the value of that particular vehicle for me. So it is checking, okay, whatever vehicle I am printing, if it matches any of this expression, it prints it. That's like exactly what is going on here. And there's something we have in pattern matching that is called the guard clause, right? And I have an example of a guard clause here so that I can explain what guard clause is really. And guard clause is basically something that allows you to evaluate an expression to see whether it matches or it does not match, right? And if a particular expression, if we check the code here, we use a guard clause. Yeah, we can use the when keyword for guard clause. If this particular expression doesn't match, it doesn't mean that the execution, the total execution will halt. If it doesn't match, it moves on to um, run the other executions in the expression, right? So if the expression for the guard clause fails, then the case for this case fails, right? So if you look at this example here, I have a string America day, and what I just want to check is I want to check when the day, like when you have like the last day, that is an end date, right? For one, when the day is not 11, that is, days of the week, when you have 10, 11th is 11th ends with th. But if you have days that has something like 21, so 21 is like 21st. So this thing is basically saying that when the day ends with 1, but the day is not 11, then you add st to that particular day and respective day like that. So if the this particular case doesn't work, then um, the case will fail. If it matches, then it will pass. That's basically what guard clause is doing. So for pattern destructuring is a programming concept that allows you to extract values from data structures, such as arrays, objects, or records using a pattern. So from the beginning, I mentioned that destructuring is basically you breaking a pattern into smaller variables. So you can either extract values from arrays, objects, or records using pattern, right? And instead of accessing elements or properties one by one, you can define a pattern that describes the shape or structure of the data you want to extract. Um, so if you're doing pattern destructuring, you can define, okay, the particular shape that you want your pattern to look like when you are destructuring. It doesn't have to be the same as the one that you know you extracted from. The structuring patterns can include default values and next step patterns, allowing for more complex extraction from data structures. So now this is an example of destructuring, like a destructuring list here. And what this basically, I have two examples. And this example is before pattern matching, that is before the pattern matching came into that three. If you want to get, if you want to print this list of shoes, that is this shoes here, this is how we usually do it before. We create the list of shoes, then we use a for loop to find the shoe in this list of shoes and print it. But in pattern matching now, doing the structuring, what I just do is I create my list of shoes, then I create a list of variables and equate it to these shoes, and I just print it. This is more readable because this will tell the user that, oh, you have a variable of different, you have different variables of list of shoes, right? And this X since it's index, it represents the items ascending order. So once I print $X, right, I get X equals to Valentino, Y equals Balenciaga, and Z equals Gucci. So it is clear, it is clearer. But for this one, someone might still be wondering, oh, what is for? What is shoe in shoes? What am I looking for? But this way, it is still better. So pattern destructuring makes your code clear and concise. Like you get to understand it to some extent if you are, just saying something like that. Um, we have destructuring using if case statements. So for pattern destructuring, we have something called if case statements, right? And what if case statement does is that it allows you to match a single pattern. So if you're checking to match a single pattern, and destructuring using if statements, yeah, what we're basically doing is that we are trying to we're trying to match a single pattern, right? And what we're trying to match here is that if vehicle, I created a vehicle variable here, and it is car name Toyota, number of wheels is 4. And what I am checking is that if vehicle case car, the string name, that is, I'm not changing this variable. This name variable is a string, and I'm not changing it. And the number of wheels is also an integer. If the vehicle is this, then it should print this. So that is, I'm just checking that if vehicle one, that is what I created here, if it matches with this value, with this pattern that I put here, then it should print this. If it does not match it, then it is going to fail. It will not print this for me. Instead, we can now add a wildcard pattern at the bottom. And what wildcard pattern does is basically it is like a default setting. So when you have your switch case expression, after putting all the cases, the default setting that you put underneath is called a wildcard pattern. So if you don't put your default, you could just put an underscore to represent, a wildcard pattern. So it's a default. It literally prints what you put at that last part under the underscore. I think I have an example like that here, just from here. So something like this underscore, then what it's going to print, this is it on the right hand side. So this is like a default setting. It's called a wildcard pattern. Right. So we have something called records here, and records are an immutable aggregate type in React, and they allow you to bundle multiple objects into a single object. They are fixed size, heterogeneous, and their value cannot be altered once it is declared. Records eliminate the need to always create classes for basic data modeling and allows both positioner and name fields inside it. I think record is actually one very good features that the that team added to that programming language, because now that allows multiple paradigms. That is, you can write both imperative and functional methods in a Dart programming language. It is just very sweet that it allows, functional programming. And functional programming is very, very cool for data modeling. And records works like very, very well in functional programming. And in this record example, I have on my left hand side a class something that has 3 properties, string A, B, C, and I have a function that returns something with the properties and assign it to a value. For records, since we have records, we don't need to create a class with multiple properties. We can just create a record, put in our property, write the function, and return what the value that we want to return assigned to each of the properties. Then we can print our values by declaring it in the main.bat. So if you are always like writing um your class like this, if you're always writing your function, maybe a function where you declare some class because you need to, write some properties and assign it to a value, and you're always doing it like this, I think you should stop now and change to this pattern. It is shorter and it is clearer. Like for me, I can tell that, oh, this is um these are properties, right? And it is assigned to this particular function. And I am returning these properties assigned to this value. And I can assign a function to a variable and print this variable and print each of these value, by calling it like this. And it's going to give me like my correct output. So now, one very interesting update they also added is the class modifiers, which is like I think one of the interesting things that a lot of people enjoyed in this update. And class modifiers, um, I know we most of us already know what class modifiers are because we already have class modifiers before, but there were some new updates added to our class modifiers, like the sealed class, the interface class. We have um, so the list of modifiers we have now is the abstract, base, final, interface, sealed, and mixing, right? And these modifiers are essential keywords that come before defining a class or a mixin. So now let's look at each of the class modifiers. Abstract class. Abstract class cannot be constructed from any library, whether its own or an outside library, unless you're doing a factory constructor. If you need something like a factory constructor in your abstract class method. Abstract class often have abstract methods that must be implemented by subclasses. Factory constructors can be used to control subclass instantiation. Yes. If you look at an example of what we have here, I have an abstract class called shape. And inside this file, I can create other classes that implement my shape, my abstract class shape, right? And I have a factory constructor because I just wanted to create like a constructor class of my shape. So instead of like, because since I cannot create a constructor class, right? I just create a factory constructor of shape and put in my function, the function I needed for this particular shape in my factory constructor. And do whatever I want to do with that in other parts of the code. So for our base class, we have the base modifier. Base modifier ensures that a class or mixin can only be implemented within the same library where it is defined, but can be extended inside other libraries. And this ensures that the base class constructor is always called when the subtype is created. All implemented private members are accessible in subtypes that implement the base class. A new implemented member, that is, whether a variable or a method in a base class, does not break subtypes. And classes that we implement or extend a base class must be marked as base, final, or sealed. So if a class, let me show this example. So this example on my left hand side, I constructed a base class, right? Called my base. Then I am implementing a subclass with my main base class, right? And what I just did is that my subclass is also a base class. So base class, my subclass implements my base. You will get no error. It will work fine. You can implement a class like this. But if you are importing your base class into another file, right? And you're creating it like this. Let's say my base subclass extend my base. Yes, it is perfect. You can do it like this. But if you're having class base subclass extend my base, it's going to give you an error. You need to add base, the base modifier, to whatever subclass that is extending the main base class that has been created. And if you have something like this, base class, other subclass, implement my base, you cannot implement a base class outside of its file that it is being defined. So this is wrong. So we have another one called the interface modifier, right? And interface modifier is like opposite of base modifier, and it ensures that a class can only be extended within the same library where it is defined. It cannot be extended outside the file it was created from. So you cannot extend an interface class outside this class. You can only extend it inside the class, inside the library that it was being defined, inside the file that the interface class was defined. Like this example now, I'm trying to extend my interface class with this subclass outside of its defining library, and it's giving me an error. But then if I implement the interface class, right, outside the defining library, then I will not get an error. Then we have another one called the final modifier, right? And what the final modifier does is that it prevents a class from being implemented, extended outside its defining library. So you cannot implement a final class outside of its library. You cannot also implement it outside of its library, right? So if you look at this example, interface of class extend my final class. You cannot extend it because you are trying to import the final class inside another library. It's not going to work. You can also not implement it. Then we have the sealed class, and this sealed class is like, I think this was like one of the major updates, right, for the class modifiers. And what it does is that it's something like an abstract class, right? And there was this video that Bob Nistrom created, and he spoke about the problem and why they came about the sealed class, right? And the reason is that they wanted something like an abstract class, but they wanted something that has exhaustiveness. So that is exhaustive, right? That is something that, you know, if you are trying to extend or implement that particular class, if any function is not added or any function is being added, the classes that are implementing or extending that particular sealed class will get the information that, oh, there is an error. So it checks for exhaustiveness, right? Whenever you are using a sealed class. So a sealed class cannot be directly extended, implemented, or mixed outside of its defined scope. It has to be inside of that particular library that you are creating it. And it provides a way to define a set of junior classes and leverage pattern matching. It enhances code safety and maintainability in certain scenarios. So I have an example here, and the example here is that we have a sealed class current state, and we have a class load state, extend current state. And if you look at here, my load state class can extend my current state because they are in the same defining library. If you check here, this one here on the right hand side, final current state equals to load state, message loading. The message is loading. And if you look at here, it says final data, switch state, load state, variable message, match equals to message, error state equals to error, success state, equals to success, and printing the data. If you look at here, it says that the type current state is not exhaustively matched by the switch cases since it doesn't match the success state. Try adding a wildcard pattern of cases that match success states, right? So it's saying that the current state does not is not exhaustively matching, the switch case that I created. So since it's not matching it, I should just add a wildcard pattern so that if the case does not match, it can just print the wildcard pattern and that solves it. So after talking about all these terms for that theory, I have I want to talk about pattern matching for JSON validation, right? And there are a lot of codes, so I'll just go through it quickly because I can't waste time. I'll just explain tiny bit of it and show you how pattern matching works. That is the code we have before that three came, and now that we have that three, how does our JSON validation? How does it look like, right? So this app is like an hypothetical app. I don't have a demo for it, but it's an app that has posts and users can like and comment on these posts. So we're just basically going to be checking. We're just basically going to be checking the data of this particular app of this particular app. So this is basically what we're looking at here. This flow is going to, this flow is basically like what I'm going to be explaining to us with the necessary code you're going to be seeing after this particular slide. And it's basically us, starting with JSON and validating the JSON and turning the JSON into a type object and then tell Flutter to display data from that object. And to do this, we have two classes in our class hierarchy. We have a class post and we have a class user. And now our JSON validation. So what JSON validation really means is that um, includes these three items I have on the screen. And one is that to ensure the properties that we really want to, validate exist on the data, and also ensure that the data types of those properties are correct. And lastly, we want to um, validate that the values match exactly what we are expecting. So that is what JSON validation really means. So these three things are very, very important when we're doing JSON validation. So this code here, this is not really like a JSON here. It's basically like a value that you get when you do JSON decode on a particular JSON. So it is like a map of values. And this is um, like a map of a post that has a post type, an ID, image path, the user, the likes, right? And if you look at this validation, so this looks quite, bulky, and there are actually many ways to write our JSON. Like if you want to validate a particular JSON, there are many ways to do it. We can do it like this. We can do it another way. And doing it like this is kind of bulky. And this was, how we do validation of JSON before that three came. And I would like to just, highlight this part. So this part talks about the key likes exist, and we're checking that the value for this key is not null, and also that particular key has an int type, right? And we also have something like this for the user. So we're checking if the user has a key called username. So now this is like the old way of doing validation of JSON before that three came. And since I mentioned that pattern matching creates like a specific shape and it is clear and concise. Now this is what we have if we use like our pattern matching in that three to create our validation, right? And what we basically have here, we let's forget this validate post and focus on the shape that we have. So the previous code I had before now results to this, and it does the same thing. There is no difference. And what a pattern basically does is that it represents the shape of a value that you want to compare to an actual value. And in this case, we want to match this particular shape. We want to match it to our JSON. So now let's look at these likes. The likes we had before was this, without patterns. We had this JSON that contains key likes, checking if the likes, the key likes is not null, and if it is integer. And basically, this sums up to this. And it has this wildcard patterns. It has this wildcard patterns. And what the wildcard patterns basically does is that it is it is telling us that the type of this particular key is integer, but we don't know what the value of this integer is, and we do not care. So that is why you're having a wildcard pattern. So the likes can be any value, but the type is integer. And we also have for the username, that is a submap for the username and location, and it also have a string type. Now, let's talk about our if case statement. So, what this if case is basically doing is that since we are trying to match a single pattern here, we're going to be using an if case statement. I mentioned earlier that in pattern matching, we use switch expressions, right? And why we use switch expressions is that if we want to match multiple patterns, then we can use the switch expression. We have different cases. But if we want to match just a single pattern, we don't need to go through using switch expression. We can just use an if case statement. And the if case statement can just match a single pattern. Sorry, excuse me. So use an if case statement when you want to match a single pattern. So now that is basically pattern matching. Now let's look at the destructuring. So now, yeah, I already have two maps for my JSON. The one that covers for the type text and the one that covers for type image. And each of them have their own properties, and they have the objects, text post and image post. And if you notice, we're also using a wildcard pattern here to match the values of the pattern. So now, remember I said that this our key likes is an integer type, and this wildcard pattern here states that it is a type int, and we do not care what the value is, and it can actually match. It can it can actually we don't care what the value of the integer is, right? and we can match the pattern like this. But then we can also destructure this pattern if we want to use the values that are being matched against. So now I will show us how we can do this. So in this version of this particular method here, I am still matching the pattern against the JSON object, but then I am returning the text post object without calling from JSON, because this is the from JSON method. And instead of using wildcard patterns, I can use variable names for the value. And the variable names for the values that are assigned to each of these keys, if you notice in the objects, they are already in the object. So text post already has ID, likes, and the user object already has the username, location, and post body. And I just assign it to them. If we're still matching the pattern, basically we just replaced the white type patterns with these things here. If the pattern matches, that will create variables and assign them to the value that exists in the object you are matching against. Then the variables can be passed directly to the text post constructor, that is the text post object that we have here. And that is called destructuring. So what we basically did is that we went from the wildcard um, pattern matching to this one, and we already have our JSON destructuring. So now this one is basically going to our Flutter code and passing our text post widget to see, okay, if it actually works or it does not work. I think time is running, and I just want to, So let's look at exhaustiveness here. Let's look at exhaustiveness. So far we have been doing pattern matching and pattern destructuring. I hope you have been able to see, how it actually looks before that three, and now after that three, after doing pattern matching, how our JSON validation looks. So now, before we were just having our text post and image post, but now that we now have video post and other, we have multiple users, and we have multiple post types. So that is our value, our data is no longer simple as before, right? So what are we going to do? So this is like from before, what we have before, right? And um, instead of creating the user, instead of creating the user to have instead of creating the user to have the username and the location, we created a map string dynamic user. And why we're doing that is because we want to be able to handle our user validation in a separate method. We don't want to include it to this particular method that we're working on. So now, since we already have multiple things that we need to handle, we will need to tweak this particular code. And tweaking this particular code, this is what we have. So we're covering for the majority of the data that we are having. If the post is text post, we get this widget. If it is image post, we show this widget. If it is video post, this widget comes up. If the post.user is normal user, we use this widget. If the post.user is a page user, we use this widget. Now, so what is now exhaustive checking, right? Based on, you know, all the things I have showed so far. So exhaustive checking is basically a compile time error. If that is possible, you know, for a value to enter a switch but not match any of the cases. And what it is like, I think let me explain it better, right? So what exhaustiveness checking does is that it's basically checking if it is possible for a value to enter a switch but not match any of the cases. And it is actually possible because the Dart compiler knows about every possible value of the item being switched over. For example, now, this switch statement I have on my screen, right? That knows that for sure, true and false cover every possible case because it's true is a boolean, and there are only two boolean types. We have the true and we have the false. So we don't even need to, add a default case because if the case is true, then it is true. If the case is not true, then it's going to be false because we're using a boolean type. So an exhaustiveness checking also has um it has always been used for enums because if you look at this enum type now, we have enum animals, dog, cat, fish, switch animal, case animals dot dog, case animals dot cat. If the animal is dog, the operation under the case will happen. If it is cat, the operation under the case will happen. If it is fish, the operation under it will happen. So now let us check um, the second example that I want to show now because if you look at this example, we don't have a case for fish, but we have a case for dog and cat, right? Let's see what will happen. Yeah. So for to take advantage of exhaustive checking on our custom class that we created, right? So instead of creating abstract classes, we can just create themed class. So our post class is going to be a themed class, and we can now extend each of the posts, that is text post, image post, extending the seal class post. And for our user, we can extend it. So we're going to be using this thing, like we're extending it in the same library that we defined it. And the main advantage is basically the sealed modifier cannot allow us to extend or implement any of this extend or implement the sealed class outside of his own library. So we everything we do here is inside the own library. It's inside the library that it is being created. So when we create our code to look like this, when we refactor our code to look like this, we are sure that every possible subtype of post is in the same library, and therefore we can know that, oh, if we miss a particular type, we know that we miss a particular type because the code will not compile since we miss a particular type. And why would the code not compile since we miss a particular type? That's because we're using a sealed class. And since we're extending a sealed class, if a type is missing, right, your code will not compile because you get an error that, oh, there's a particular type that you've not added. And we also do not need to add a default case. It says the type post is not exhaustively matched by the switch cases since it does not match the video post. And why is this giving us the error? Look at what happened. So I commented out this case video post, right? And when I commented it out, I got this error on my switch statement. It's telling me that the switch statement, there's an error that is not complete. And what the error is that the post is not exhaustively matched by the switch page because it cannot find my video post, right? So I can add a wildcard pattern to check for the, to save, to adjust, the omission of the video post, or I put in the case that matches the video post. So exhaustiveness checking works very well with sealed class. When you have a sealed class and you extend other classes with the sealed class, when you try to create pattern matching, or when you try to create switch expressions for that particular class that you're extending, if you don't if you don't include a particular type and you don't add a wildcard pattern, then you're going to get an error that, oh, there's this particular type that you've not included. But let's say, for instance, you're just using like an abstract class, or you're using just a normal class. If I omit any um, type or any case in my class, I will not get any information that, okay, this thing that I am trying to do, it is wrong, or this thing I am trying to do is not correct. I will not get an error. I can just continue like that. So now that I added it, this is fine, and we can use this switch expression to get our correct auto widgets. Yeah. So our post widgets, then our auto widgets. So it returns each of the posts: text post, image post, video post, author, normal user, page user, admin user. So this is pattern matching. Now let us look at pattern destructuring to be able to understand better. So once I explain this pattern destructuring, then we can wrap up. All right. So this is the example from the first time before we did image post and video post. So this one is basically a text post, right? So now let's say we now have this particular case. So we refactored from there to this one, getting the post widget. So getting the post widget can cover for all cases, because now we have 3 post types, we have 3 user types, so we have 9 total cases to match against, right? So now let us talk about it in bits. So what we are doing basically now is called object destructuring. There's something called object destructuring in that 3, right? And what this particular one is saying is that, oh, I want to match against any post that is type text post, and also has a user property of normal user. So that is basically what this is doing, right? And if you look at these 2 lines of code that we have here, the 2 lines are the same, they look alike, but then the second line of code looks like any other named argument, like in that, right? So if you are naming a variable that you are destructuring the same as the property name of the object, the property name can be inferred or left out, right? So now, this particular post widget we have handles all the cases, yeah. And as you expect, the pattern matching algorithm is smart to ensure that, oh yes, we have written code that matches every combination of values, that we're not missing anything. Everything is there and it works recursively. And if I comment out any of this any of this case, let's say now I comment out the paid user, I will get an error. I'll get an error that, oh, there's a particular case that you did not match. So now we have what we call records. So after records, wrapping up, we have what we call records. And if you look at this line, that line that is being highlighted here, you notice that we're returning two widgets from this method. And the two widgets that we're returning is what we can actually do when it comes to record. Remember the line of code I showed that we could create our um, properties in that curly braces, like as a parameter. So the string A, string B, string C, that is like a record. So now, yeah, we are creating a function, and we are returning two widgets using records. So, like I said, records are a collection type that can hold an arbitrary number of elements, and those elements can be of different types. So this first widget and this second widget can be different type. My first widget can be of string. My second widget can be of integer, right? Records are very, very good. They are very, very useful for passing multiple values around that are logically linked. And so now let's look at the next one here. Okay. So this code now, this is how our build method looks like. And in our build method, what we're doing is that we're calling the get post widget. And then if we say we should destructure this, we're going to get, to destructure this, we're going to get these two variables. And these two variables, they use record syntax, that is the post widget and the author widget. Although before that three, right, we could return our column like this. We could return our column from the get post widget method. We could return our column like this, but this can be a problem. This can be a problem because yeah, basically adding unnecessary. So let's say we have something like this here. In our get post widget, we are returning a column with children posts and author. That's the children. Then in our build method, we're also having something like this. This is basically like you're adding unnecessary, stuff to your application. But then, but then there are options for returning multiple widgets. But using records does not require us to be using, all this unnecessary, to be writing unnecessary code. So we can basically have something like this after using our record and doing pattern destructuring. So I also have more examples, right, which can be checked in data, and we can see that what we have before in that programming language and what we have now, thanks to that three new features, allows us to, write cleaner code. Our code is more clear, it is more clean. Um, it is even, it is beautiful. It is beautiful, right? And you can understand better, and you can, when you can actually expect a case to happen even before the case happening. Something like error handling now, especially when we are trying to, get data from APIs and we want to load data into our app. If we handle cases using pattern matching in our, let's say, our data sources, our repositories, and if the data does not, come in as supposed to come in from the backend, since you already, expected a case like that and you've done pattern matching, it's going to return an error that, oh, this error is coming from the backend, not coming from me. So it is very, very cool for, error handling, right? And that three is very, very, it might look complicated, but with time you can, get adjusted to it, just one at a time, one at a time. So I have some resources in my slides that you can actually check out. The slide we shared, and you can check it out. And there's also a code lab that the Flutter team prepared that you can, practice to be able to, write your own dactyl code better. Thank you so much.
Excellent, excellent. Thank you so much, Maria. I think that it's very rich, and definitely I need time to digest that one. But look at the DAR3, especially the pattern matching for JSON validation and the record. Oh my God, that's very beautiful. Yeah, thank you very much. And I will share Maria's the PowerPoint to all the people participate the event this morning, this evening, and I know Maria's local time is it's 1:00 a.m. Yeah, thank you so much. Thank you so much. And so right now we only have one question here in our chat, and so Maria, if you have time, you may just quickly answer that one. So I think that he asked for the car example. Yeah, will the guards clause run if there are another more generic case at the start or switch?
Oh, yes. So for the guard clause, if there are more generic case at the start of the switch, that is, if we have more cases apart from like the car stuff, if the pattern does not match, right? That is the guard clause I have. If the clause in the case, if it does not match, right, it will it will fail. But if it matches, it will it will run, like it will print the correct output and other things will happen. So basically what the guard clause does is that it doesn't stop your execution from running. It's just like um reason why we have okay, let me use this example, our if and else statement, right? So let's say we have an if statement, then we have an else statement, right? If the if statement doesn't run, it prints the else statement, yeah. But then in cases where we have if statement, else if statement, and else statement, if the if statement runs, your program has already, like, finished running. It won't check for the else statement. But when you have switch cases, if the case one if the case one checks the operation, it prints the value. Case two checks the operation, it prints the value. So in the pattern matching, right, if you have more generic cases at the start of the switch, if that particular guard clause for the car example, if it matches the pattern, it is going to run. If it does not match the pattern, then it will fail and it will continue the execution in the switch expression. I hope I was able to answer that.
All right, excellent. So far, we don't have any more questions, and I want to thank you, everyone. Thank you, Maria. It's fantastic. I hope we have more session next week, next month, and welcome everyone to join. Thank you so much. Good evening, good night, good morning, or good afternoon. Okay.
Thank you. Bye.
Bye bye.